Okay, so this is our 2022 mock from ExamCraft, and we're on question 8 here. Question 8, if you're flicking through these, it looks like it has to do with a little bit of functions, because there's a graph here that we can see straight away from just scanning through the paper. If we're going to draw a graph, it's going to bring in functions, okay? Our pattern stuff can overlap with our functions, and when we start reading this, that is kind of what we see. Okay, question A says, each year a shop sold 20 more laptops than the year before. In 2015, the shop sold 180 laptops, 200 laptops sold in 2016. Okay, so how many were sold in 2020? A few different ways of doing this. If you want, you can do out a table, okay, to show how many laptops were sold each year. Okay, the reason why I think that actually in this case, this could work out slightly better is because in the next question, I'm going to have to draw a graph. So no harm for me to have a little bit of information here. Okay, so I could do out a table there for 2015, 2016, 2017, and so on. 18, 19, and 20. Okay. So it started off there with 180 laptops and then 200 laptops, and it's just going up by 20 each time. So 220, 240, 260, and then 280. Okay, alternatively, we could have said, okay, well, in 2015, there was 180 laptops sold, okay, plus 20 for each year that's passed, so plus 20 for each of the 5 years that have passed, so that we get 280 laptops. Okay, here remember you haven't actually given your full answer when you've completed this table. Okay, you need to write your conclusion, what you're concluding from getting that on the table. So in 2020, 280 laptops were sold. Okay, then they ask us to represent the stuff on a graph. Now remember, when you're increasing by a steady amount every year or every term that you go up, we're looking at an arithmetic sequence, okay, an arithmetic pattern or a linear pattern. So if I look at this and it has a constant first difference of plus 20, plus 20, plus 20, plus 20, plus 20, that means that on my graph here, I'm going to have a straight line. Okay, so I can get my pencil and I can start plotting each of these points. So 2015, I'm at 180. So here, 2016, I'm at 200. So here, okay, and I could do that for each of my points, or I could recognize it is linear, okay, it is going to be one line. How many points do I need to draw a graph that is a straight line? I need 2. Okay, 3 is enough to make sure that we really haven't made a silly mistake somewhere. Okay, so I can plot my first and my last and one along the way, that when I get my ruler out, okay, there is one line there. Now, let's just give it a second to get my ruler back. There we go. Okay, so that is my line. Don't have a blunt pencil in the exam, but do make sure that it's dark because your exam is being scanned in. Okay, now, again, if we have enough time, it is worth just plotting all the points and making sure, just to check, is my graph right? Okay, so if we were to plot all the points, 2017 should have been across from 220. Okay, 2018 across from 240, and 2019 across from 260. Okay, and then we've already done our 2021. Okay, so it's a straight line graph there. This says find the slope of the graph and explain what it means in the context of the question. This is what catches people out a lot, okay, in the context of this question. That means put it in English. Explain, okay, means put the stuff in English, okay, not in maths, in English. No such thing as things like equals this and whatnot, okay. You're explaining it in English words. No math symbols. Okay, in the context of this question means use the words that the question is using. Okay, laptops and years, okay? That's the kind of stuff that they want. In the context of this question, Okay, we are looking at laptops sold and years. Okay, so you're looking to put some of those words into the answer here. Okay, but before I go and do any of that, I do need to find the slope. Okay, so find the slope of the graph. So the slope is the rise over the run. Okay, so take any two clear points on the graph. Okay, so remember when we're finding a point from a graph like this, okay, you don't try and find a point, let's say, here. Okay, what I just coloured in there. That's not clear. There's no information clear on that. That's somewhere between 2016 and 2017, and it's somewhere between 200 and 220 that I don't know for certain. Okay, so what you're looking to choose when you're finding the slope is if they've given you 2 points, which they have, okay, then use the 2 points that they gave, or from the graph, choose 2 points that are clearly, like they have clear information. So they're at a corner of a box, okay, and that way you can follow that line straight down. So I'm looking at this line here. I can follow it straight down and I can follow it straight across. Okay, so if they're at a corner of a box, one of the small boxes, it means that you'll be able to follow that line down and across. Okay, here I have 6 different points that I could choose from. Okay, 6 different clear points that are up here and down here. Okay, and remember what our slope is. Okay, so the slope is the rise over the run. You could have chosen these points out and said, for example, this point here as an actual point would be 2018, and my y coordinate 240. Okay, if you do it that way, you can use our formula from our coordinate geometry stuff. Okay, y2 minus y1 over x2 minus x1, or just remember that the slope is the rise over the run. Okay, so let's say I take this point here and this point here. Okay, for this one, how much does it rise between 2 points? Okay, so from there up to this box here, it's gone up by 20. Over, and then the run across, so how much it went from here to here. So it went from 2015 to 2016. So that means that it went up 1. Okay. So my slope there is 20 divided by 1, which is 20. Okay. If I had chosen the first point with this one, I would have gotten 40 over 2. Okay. Or the first and the last, I would have gotten 100 over 5. Regardless, I'm getting a slope of 20. Okay. So what does that mean in terms of my English then? Okay, explain it. So my slope is 20. Okay, so my slope or my rate of change is 20. Okay, rate of change came into slopes a lot when we looked at our calculus stuff as well. Okay, so here we have figured out that the rate of change is 20. Okay, so that's it in English, but it's not it in terms of my question asked. Okay, and technically I even shouldn't have written this equals 20. I should have said it is 20. Okay, but the question's not finished. I need to say it in terms of laptops sold and the years. Okay, so each year the number of laptops sold. This is actually kind of nice because they actually pretty much gave this to you in the original question. Okay, so the number of laptops sold. Now, you can, some people kind of gave like things like it's a positive slope, so it's an increasing number of laptops sold. Okay, that's great. It is increasing, but that's just not specific enough. Okay, so each year the number of laptops sold is increasing. It absolutely is increasing. Okay, but we need to just say more than that. Okay, specifically, what about the 20? Okay, so yes, it's increasing. Okay, because we have a positive slope. Okay, so is positive, it's increasing. Okay, so now we've mentioned the fact that it's a positive slope. Okay, but we still haven't mentioned that number 20, so you have to mention that it's increasing by 20. Okay, so what's kind of nice about this question is in that original sentence here, it says, each year a shop sold 20 more laptops than the year before. You literally could have copied that sentence straight down here. Okay, then we are looking at an area question. Okay, area and volume. So question B says, laptops are packaged into cardboard boxes, the bases of which are made from a piece of cardboard, and it gives me a length. So the length is 42 and width is 32. Square pieces of side X are removed from these lengths. Okay, so they are removed from each corner and the flaps are turned up so that the open box is formed. Okay, so in this box here, when I turn up these sides here, okay, they're saying they're turned up to make a height. Okay, so straight away here, I'm going to add in to my diagram, okay, that they have told me there that that height is X. Okay, so the height is X. So from these sheets that started with a length of 42 centimeters and 32 centimeters, okay, X was cut from each of those twice, okay, once at each end. So the length, okay, it was 42, but then they took off this X and this X, okay, which means it's 42 minus 2X centimeters. Now they were quite nice here because they actually did say in terms of X. Okay, so you were expecting an X in your answer. Okay, you didn't actually have to write in the centimeters part here either for the marks. Okay, so that was perfect. And then the width likewise. Okay, so the width, the exact same thing. It was 32 centimeters. And then from that, they took away X up here and X down here. Okay, so it's 32 minus 2X. Okay, and my units again is centimeters. Okay, so that is my length and that is my width. And then the box has this height X that they had told us about. Okay, so X was turned up to make the sides, so it means it has a height X. Now, the question says, show that the volume of the box can be written as this. Okay, show that means that you don't start with this. Okay, you answer the question as basically find the volume and then get this as your answer. Okay, so find the volume of the box basically. Okay, so to find the volume of the box, first thing we do is we write down, well, how do we get the volume of a box? How do we get the volume of a cuboid? Okay, so the volume of that is the length times the width times the height. Okay, now if you didn't know, for example, what the height was, you're still better off trying to at least start filling in what length did you put up here, okay, and what width from what you had up here, okay, so that you have at least some correct substitution into this formula if they allow incorrect answers from part 1 to be used. Okay, so even if you don't see that the height is X, okay, fill in, well, what was your length from part 1? So 42 minus 2X. And what was the width from part 1? So the width was 32 minus 2X. Okay, now some people got that and they didn't know what the height was that they were multiplying by. Okay, now if that's the case and you multiply these out, look at what happens when you multiply them out. Okay, just watch what happens when we multiply those first two sets out. Okay, so remember 2 brackets here. Everything in the first bracket has to multiply everything in the second bracket. So 42 times 32, I'm getting 1344. Okay, then, so that's 42 by 32, then 42 by minus 2x is going to give me minus 84x. Okay, now I've multiplied the first part of the first bracket by everything in the second, so I'm going to move on to the next part, the minus 2x by everything. So minus 2x by 32 is going to give me minus 64x, and then a minus 2x by a minus 2x is plus 4x squared. Okay, so because I still don't know the height that I'm multiplying by, when I simplify this, okay, when I simplify it, look what I get. Okay, let's put the x squared part first, okay, because that's how we usually see quadratics. When we have multiple x's with different powers, okay, we usually see the highest power first. So 4x squared, okay, then minus 84 minus 64, so that I get minus 148x, okay, and then plus this 1344. Okay, some people got that far, but you didn't see what the height was. Okay, if you look at this as your answer, and I missed a squared here. If you look at this as your answer, okay, and this is what they want you to get, what's missing from this? What would you need to multiply every term by here to get back to here? Okay, well, there's an x that needs to multiply this, this, and this. Okay, so then you say, okay, wait, well, I'm just going to guess that the height is 6, or is x. Okay, if you guess that the height is x, then this is going to work out correctly for you. But also, when you then look back and say, would it make sense for the height to be x? Yes, it does, okay? They were folding up these parts that had a length x each side, so the height made sense for it to be x. Okay, now it doesn't matter that I didn't have that filled in yet, because remember, when we multiply three different brackets together, you have to fully multiply 2 out together first, okay? So it didn't matter if I started by multiplying the first two, okay, which is what I done, and then multiply by the third. It doesn't matter if I decided to do it that way, or if I decided to, let's say, do the second two together, and I multiply that out fully, and then when I get an answer for that, multiply by this one. Regardless, okay, I haven't actually wasted time here by just multiplying the first two together first, okay, because I can't multiply by the third until I finish multiplying by the first two. Okay, and then I need to finish multiplying. Okay, so now I just need to multiply everything here by x, so that I get 4x cubed minus 148x squared plus 1344x. Okay. Now the question says, by using calculus. Okay, calculus meaning my derivatives, my first derivative, my second derivative. Okay, so up here they gave me what v is. Okay, so I can find the first derivative of that, dv dx. Okay, you don't even need to write it like that. You can write it in whatever way you want. Okay, it's up to you. Okay, even literally write out the words first derivative, but I'm just noting this in that calculus. Okay, I haven't even finished reading through the question. When it says calculus, I know I'm going to have to use a derivative. Okay, so by using calculus methods, find the value of x which will give the maximum. Now, they were really nice to tell us using calculus methods. Okay, we know to find a max, that's what we usually do. Okay, to find a max, we usually get the first derivative, okay, so the slope, and we say, when is the slope 0? Okay, so remember that if we're asked ever for a max or a min, okay, what we're looking for is, where is the slope 0? Okay, so as soon as we see max or min, we are used to finding, okay, what is the first derivative and let it equal 0. Okay, so find the value for x which will give the maximum. Okay, so I'm going to let the first derivative equal 0. And then hence find the maximum volume. Okay, so remember, once we've found x, we've only found the maximum volume we can get. Okay, or the maximum that, I'll just choose this out with the graph. if we found this part where the slope is 0, okay, we have found, well, what is the x coordinate for that? And they want, well, what is the actual volume that gives us, okay, which is on the y-axis here. Okay, what volume does that give us? So we're going to need to sub it back in to this equation here. Okay, so if you didn't get that, perhaps now pause the video and try it yourself. Okay, we need to find the first derivative first for the volume. Okay, so my volume was found in the last part, and even if you didn't get part I, they actually gave you what the volume was, so that was very nice of them. Okay, I'm going to write it out first before I get the derivative of it, just to make sure, because I am likely to make a silly mistake if I'm constantly looking back to the last page to try and get that and then write it down here. Okay, I want to avoid making silly mistakes. For example, I've already made one. Okay, I want to avoid making silly mistakes by making sure, okay, have I written this down fully correctly before, and then I can just literally get the derivative one step under the other. Okay, so if I read that with an x squared, I would have made a mistake if I went straight into my derivative, if I went straight into dv dx, and I had read that as 4x squared. Okay, then here in my dv dx, I would have made the mistake of writing it as 8x, okay, and the examiner wouldn't have understood why I just got the derivative of that incorrectly. Whereas if I had have copied it down here incorrectly, one, I might have been more inclined to actually see my mistake, okay, and two, at least if I had written that down with a squared, the examiner might see, and they might allow me to have gotten that incorrect, that I had basically written it down incorrectly from above. Okay, so write down what the volume is before you go and get the derivative of each. So that's actually incorrect, but I'm going to leave it there for a second. Okay, minus 148x squared plus 1344x. Okay, so there's a different power on each of my x's here. That makes sense. If any of them had the same power, then they would have just been simplified for my volume expression. Okay, so it makes sense that they all have different powers. If they all have different powers in the original, I'm expecting them all to have different powers in the first derivative. Okay, so here, that's the reason why I left the 8x there. Okay, if I had done one thing incorrectly, let's say that first part, and I wrote that as 8x. Okay, let's say I done that incorrectly, and then over here I started doing it correctly, so that I got minus 296x. Okay, here I would see, oh look, they simplify. That's weird for me to have gotten two of the same powers in the first derivative, because in my original I didn't have any two of the same powers. Okay, so that's where I'd kind of be like, oh wait, I must have made a mistake here as well. Okay, so that first expression, remember, our rule for getting the first derivative, it's multiply by the power and reduce the power by 1. Okay, so here I'm going to get, so multiply by 3 to get 12, and then reduce the power by 1 so that I get a squared. Okay, then I have my second term done, and then the last part there, okay, in the original, if there's an x with no power, then it's just the number in front that's carried down. Okay, so we done that loads in when we were first looking at calculus, okay, and we went through why that was the case. So this is my first derivative, okay. I now have gotten 4 out of 15 marks, okay. To get the other marks, I need to register that this here, for a max or min, is equal to 0. Okay, my slope is equal to 0 gets me a max or min. So here we go. I need to now find what is x. Okay, what type of expression am I looking at here? I'm looking at a quadratic. Okay, so I need to solve this as a quadratic. Now I can do that two different ways. I can use my minus b formula, or I can just factorize and solve. Okay, now if I was going to factorize and solve, or even if I was using my minus b formula, honestly, I'd look and see, these are really high numbers. Is there any way that I can divide across by a number just to make the numbers smaller? Okay, and I could see there, firstly I'd probably check, are they all divisible by 12? Okay, so are these two numbers divisible by 12? Because then I have a quadratic where the number in front of the x squared is 1, which is my favourite type of quadratic. Okay, if not, I check for like 6, okay, and then I check for 4, and I see 4 does go into all of them. Okay, so I am looking for what different things go into 12, and if they go into 12, do they go into all the rest? Okay, so 6 didn't go into the rest, but 4 does. Okay, so I'm going to divide across by 4, so that my quadratic is going to be a 3x squared minus 74x plus 336 is equal to 0. Okay, so two ways I can do this out. I can use my minus b formula. If you're using your minus b formula, remember you're stating before you start what is a, what is b, what is c, okay, because you can get marks for that in itself. I'm going to do it using our factorising. Okay, the number in front of the x squared is not 1, which means it is a slightly longer method of factorising where we multiply the last number by what was in front of the x squared. Okay, so instead of my factor pairs just of the last number, which we could do if this was a 1 in front of the x squared, okay, instead of doing that, I have to multiply here 3 by 336. Okay, so 3 by that, so is 1008. So I am looking for what multiplies to give me plus 1008 and adds to give me minus 74. Okay, so to multiply to give me a plus means that the signs have to be the same. So I'm going to list out different things that multiply into 1008. Okay, for example, 56 and 18. Okay, now they're both pluses, so they'll multiply to give me a plus, but they'll add to give me a plus, and I want them to add to give me a minus, so I should have made them both minuses. Okay, so 56 with minus 18, okay, that actually works out perfect. They're going to add to give me the minus 74 and multiply to give me the plus 1008. Okay, so what we done next in these is we rewrote that middle part, the minus 74x, we rewrite that with these two numbers written in. Okay, so the 3x squared is going to stay the same, but then the minus 74x is going to be written as, I'll make the green a little bit darker just to make sure. So the minus 74x is going to be written as minus 56x minus 18x. Okay, and then I'll carry down my plus 336 and my equals 0. And now I can factorise these using my 4 terms, my grouping method. Okay, so that means that the first two together with highest common factor, so that I can take out a 3x and be left with x minus, what's 56 divided by 3? Okay, doesn't go in. Okay, so 56 isn't going to be divisible by 3, so I should have put these in the opposite order. Okay, so I'm just going to change that to being a minus 18x, oops. So it's going to be a minus 18x and then a minus 56x, because that way now 3 actually goes into 18. Okay, so 3 by what? 3x by what is giving me minus 18x, and I know that it's minus 6. Okay, and then I'm going to go on to the next two together. So the minus 56x and plus 336. Okay, usually we take out the sign from what is in the middle there. Okay, just as a go-to. Sometimes we might need to change it, but usually that works out for us. Okay, and then I say, what's my highest common factor between 56 and 336? And I get that it's 56. Okay, and then that multiplies by an x to get me back to minus 56x. And it has to multiply by a minus to get me to a plus. And a 6 to get me back to 336. Okay, and that's equal to 0. I'm on the right track now because inside both of my brackets is the same. So I open up 2 sets of brackets. I put what was outside the brackets in one bracket together. And I put what was inside the brackets in the other bracket together. Okay, so I have 2 things multiplying to give me 0, which means I let each bracket equal to 0. So I get 3x minus 5 is 0 and x minus 6 is 0. Okay, so I have 2 values. Here I have that x is going to be 5 over 3. And here I have that x is 6. Now, one of these is a max and one of them is a min. Okay, so when we think about it, a cubic, okay, what does a cubic look like? It goes up and down. It's not like a quadratic where it just has one turning point. It has 2 turning points. Okay, so it has, here we have 6 and we have 5 over 3. Okay, so if we think about this, a cubic could look like this or it could look like this. We don't know which of these x values is the max or the min. Okay, so what we need to do is we need to find what is my matching volume here for each of these. One of these is going to give me my maximum volume, and one of them is going to give me my minimum volume. Okay, so we have to find the matching volume for each of these. Whichever one's bigger is the maximum, and whichever one's smaller is the minimum. Okay, so I have now found the x coordinates for this part here and this part here, but we need to know, okay, what are their actual volumes that match both of these. Okay, so I'm going to get the matching volumes. Okay, I'm getting the original equation. Okay, so remember, we're used to doing this anyway when we find the slope. Okay, when we're finding the maximum or minimum, we're used to subbing them back into our original equations to find matching y values. Now we're just finding matching volume values. Okay, so I'm going to sub them back into my originals. Okay, so my volume, if x is 5 over 3, and I'm going to get my volume when x is 6. Okay, so I'm going to sub back into this formula up here, and I'm going to do that. I'm going to sub in for that and not do any of the maths. Okay, plus 1, 3, 4, 4. Okay, so first one I'm going to sub in for is 5 over 3 for x. Okay, and I'm going to get that volume. So I'll just sub all that into my calculator there. Okay, so 4 by 5 over 3 cubed. I'm going to put this fully, I'm literally putting it in bit by bit in my calculator. And what's really nice about me doing this now and doing it well in my calculator is that when I move on to this one, I literally will be able to go back to this and just delete what's inside each of the brackets. Okay, plus 1344 by 5 over 3. Okay, so this here is going to give me a volume of 1847.407 recurring. Okay, so 407, and we were looking at things in centimeters earlier on. Okay, so my answer is in centimeters, and I'll do the exact same thing out. Yes, I have it already subbed in here, and I can literally just go back to the brackets of my calculator, but I'm still going to write out what I am typing into my calculator. Okay, we have to show the examiner what we are doing. We can't just be coming up with random numbers. Okay, so write it out, what you're doing. Okay, so here I'm subbing in 6 everywhere there was an x. So I can just press the left button in my calculator and put in a 6 then Everywhere I had a 5/3 in brackets. And we get a volume of 3,600 centimetres. Okay, so what we can see here is this 5/3 point here. Okay, 5/3, that was giving me a volume that was the lesser of the volumes. Okay, that was lower down. That was a smaller volume. This is the bigger volume. So this must be the min, this must be the max. This was a smaller one. Okay, and one is the min, one is the max. So the min is the smaller, the max is the bigger. So the max here, when x is 6, is 3600. Okay, we do want to show the examiner that we know that this is the value, the matching maximum volume, and not this. Okay, so what I will do is I will get my highlighter out, or I will get a different colour pen, not red. Okay, and I will write down that that is my value for x, and this is my matching max volume. Okay.